This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will walk you through the solutions to exercise 2, questions 1 to 4, which were on variables and arrays. Starting with question 1, we're told to create the following matrices. A as a row vector, using spaces to denote the elements in the vector. B as a matrix, using a semicolon to denote the different rows within the matrix. Lastly, C as a column vector, using the semicolon again to denote the separate rows. The first part of question 1, part A, was to assign to the variable x1 the value of the second column of vector A. We type x1 is equal to A. Then looking at the matrix, we can see that it contains 1 row and 4 columns. Therefore, using the round brackets, we type 1, indicating the row, comma, then 2 to denote the column. This assigns the number 17 to x1, which we can see is the correct answer. In a similar fashion, we are asked to assign the third column of matrix B to variable x2. Since we want to denote all the rows in the third column, we use the colon notation, comma 3. Then, x3 should be the third row of matrix B. Therefore, typing 3, comma, colon denotes all the columns in the third row. Lastly, for part D, we want the first row of x4 to equal the first 3 values of matrix A, and the last 3 rows to equal matrix B. Firstly, we use the square bracket notation to denote that it contains a matrix, then typing A, 1 for the first row, comma, then colon in between the elements 1 and 3, to note that we require the values from column 1 to column 3 of matrix A. We finish by adding B to the end of the statement. This gives us a matrix of 3 by 4, containing the first 3 elements of vector A in row 1, and the rest of matrix B making up the second, third, and fourth rows. Using the CLC and the clear all commands, we can clear the command window as well as deleting all the variables we've created before we move on to question 2. We are given the following matrix. The question asks, what command will produce matrix B? Looking at this matrix, it looks like the first row of B comes from the first row, second and third column of A. The second row of B looks like it comes from the second row of A in the first and second columns. Creating the first row of matrix B starts by noting the first row, second to third columns of A. The second row of B therefore consists of row 2, columns 1 to 2. You can see that this returns the matrix we were asked for. Again, we use the CLC and clear all commands, so there is no confusion before we start the next question. Question 3 asks us to create the following matrices. Now that we've created these matrices, we have to perform some operations. The first of these is A plus B. That is simply the case of adding element by element matrix A with matrix B. Next, we perform a matrix multiplication of A times B. To give an explanation of how this result was calculated, the first element 6 is created by adding the result of the multiplication of the elements in the first row of matrix A by the elements of the first column of matrix B. This is 1 times 1 plus 2 times 1 plus 3 times 1, which equals 6. This is repeated for all elements and leads to the production of the AB matrix. We can only perform the matrix multiplication of these two matrices if the number of columns in the first matrix equals the number of rows in the second. We're asked to add A to C. This returns an error because A and C are matrices of different dimensions. The next one we are asked to try is B times A. This returns an answer because the matrices are compatible. But you'll notice that this is different for the previous calculation of A times B. This is because the elements are being multiplied in a different order. Next, we have B minus A. Again, this is possible because they have the same dimensions. Each element is being subtracted by its corresponding element in the other matrix. The matrix multiplication of A times C is compatible because the number of columns in A equals the number of rows in C. C minus B does not work, as you can see, and the last one it asks us to try is C times A, which of course won't work because they are incompatible. There are 2 columns in C, but 3 rows in A, thus leading to this error. Question 3, part B, asks what's the difference between A times B and A dot times B. This is a very important difference. As we've seen already with A times B, it is the matrix multiplication. A dot times B is the element by element multiplication. Trying this out, you will see that the answer is completely different. Question 4 is all about solving systems of linear equations. Whenever you see that in MATLAB, you know that you will most likely have to use the left division operator to solve these equations. In 4, part A, the system of linear equations is of the form AX equals B. First, we note down the matrices and the column vector A and B. A is the matrix with the coefficients, and B is our column vector of the right-hand side. To solve this system, we type X equals A, left divide B. It returns 2 elements, which are the answers to X and Y in this equation. We can carry out a very quick check to make sure that these answers satisfy our equation by defining a matrix C, which equals A times X. This returns the same elements as we originally entered for column vector B. Parts B and C of question 4 are completed in the same fashion. I will clear the workspace and command window first to give us a blank canvas. This gives us part B's results for X, Y, and Z. You'll notice that here in part C, where there are no specific X values in the equation, a 0 value is entered, i.e., since the second equation has no X squared, a 0 has been entered into the matrix. You can see the solution for X contains 4 elements corresponding to x1, x2, x3, and x4 in our equations.
This production is copyright the University of Edinburgh.